Okay, sorry about that. Okay, so exponential functions first, where do they come from? They come from here, y equals a times b to the x. Okay, I want to address first the things students kind of have misconceptions on. A and b are just numbers, okay? So a and b are just numbers. So they could both be 2, for example. They could say 2 times 2 to the x. So the way you tell the b apart, which matters a lot, is the b will always have the power to the x. Okay, so it's always going to have a power of x. That's what makes it exponential, okay, that it's a power to the x. And so there is some little misconception of knowing who's the A, who's the B. So I want to show you some really quick examples. That way you can tell them apart. Okay. So let's say you had this. Let's just write these 4. 2 times 3 to the x. Let's say you had y equals 3 to the x. Let's say you had a y equals negative 3 to the x. Okay. They will always all have an A and they will always have a B, A and a B. Okay, so the first example is really obvious to tell, right? This is the A and that's the B. Okay. But on the second example, it's not as easy to tell. Is that 3 an A or a B? A B, because it has the power to the X, okay? So that's a B, but I just told you that they have to have an A. So what would be the A? Okay, so half of you, if I were to ask each one of you, probably half of you would say 0, half of you would say 1. That's usually the case. But what happens when you multiply something by 0? It's 0, so we don't want to use 0 because then that would make that disappear, right? 0 times anything is 0. So it's actually a 1, right? Because if you multiply by 1, you don't change it. It's just the same thing. So 1 times 3 is still 3. So there's the first misconception. Does that make sense, guys? Okay. So let's talk about that. So one thing that I want to say for these problems that we're going to do, B will not be negative. Okay, for what we're going to do today and tomorrow. So this B right here would be a 3. Okay. Just like this B is a 3, this B is 3. So the B is 3. So what would the A be on that one? Negative 1. Does that make sense? So another way to write this would be like this. So it's negative 1 times 3. Okay, so the A is the negative 1. Does that make sense, guys, so far? Okay. Because the B has to be positive, right? So that's why it can't be negative. Okay, I wanted the first part, but before I do the first part, I need to introduce you to something called Euler's. Hopefully I spelled that right, Euler's number. It's a universal number. It just happens in the universe. It's always true, like pi. For example, if I ask you what pi is, you guys would answer pi equals 3.14, right? You learned that since like forever. Euler's number is another one like that. Okay, it's a E like this. It's been in your calculator, not the blue one, but the TI-84. But you've never noticed it because you probably never had to use it. But it's just like pi. But Euler equals approximately 2.71. And it goes on. It's an irrational number. It goes on forever, just like 3.14 does. Okay, but what you need to know is just that it's 2.71. We're going to be using Euler's number. Everybody good so far what I mean by that? Okay. So part 1. Let's do increasing versus decreasing. So for exponential functions, we can't say increasing, decreasing, but we use other words because we use them so much and so many times in the real world. So increasing, we would refer to growth, because growth is increasing, and you guys heard the other word before, right? Growth and decay. Okay. You use those in other classes, in science classes, chemistry perhaps, okay? Growth and decay, okay? So where do they happen? Who determines, what part of the equation determines if it's growth and decay? Is the base, the B. Okay, so I forgot to put that here. B stands for base. Okay, this is the base of the problem. Okay, the base. The base, that's why I was trying to like make it really clear who's the B and who's the A, because the base tells you if it's increasing or decreasing. So how do we know? Okay, this is really simple. So we know it's increasing if the base is bigger than 1. Okay. So that number, which has the x power, is bigger than 1. So examples of that would be like 2, right? 2 is bigger than 1. 5, 100. Would E be a growth? Yes, because E is 2.71, right? So E would be an example. Okay, all those numbers are bigger than 1. Decreasing, not negative. Okay, not negative, but between 0 and 1. Those are still positive numbers, but they're just less than 1. So examples of that would be 0.5, 1/4, 3/5, etc. Okay, so those would be decay. Okay, and so let me show you guys now a graph of what these look like. Now I want to go ahead and tell you these will have asymptotes. They're going to have HA, horizontal asymptotes. This particular example will have it right here, right on the x-axis. So this particular example has a HA at y equals 0. Okay. I just want to show you the most basic growth, most basic decay. Okay. So here we go. This would be a growth. So growth starts off really little. Like an example I can think of is maybe like COVID. You know, when COVID started, there was just a few cases, and then more cases, right? More cases. So it starts really slow, really slow, really slow, and then before you know it, there's millions and millions of cases. Okay, that's in the English language, you'll hear that a lot. It exponentially grew. It just means it grew really, really, really fast. Okay, and decay is the opposite. You have a lot. This is like my money. You have a lot, and then really fast you have no money. Okay. Decay goes down, 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 down. Okay. Is that okay? Makes sense so far? They'll never touch because of the asymptote. So it's going to always decrease, 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 but it'll never touch. Very good question. Okay. Okay. Everybody good so far, guys? Any other questions? No? Okay. What can I show you now? I'm going to show you transformations. What part are we on? Part 2. Okay, part 2. Transformations. I think I'm going to split this up because